Now return to 1524 Lavista Drive, Decatur, Georgia, United States. And we are on now the disorders of the bone and bone cells. Once again, your student, Dolphy Gilpin, here in microbiology analysis, being supported by our OMAX microscope. And we have just done a brief video class of osteoporosis. Now we are going to do disorders due to some of these processes not being completed or not being done, or if it is done, it is not done perfectly. So we have now first disorder of the bone we call Osteogenesis Imperfecta. We say now that Osteogenesis Imperfecta is a group of genetic disorder. And it's characterized now by fragile bone. Yeah, a group of genetic disorder characterized by fragile bone. Now, it is caused by defective genes. Defective genes, and these genes affect how the body makes collagen, which is a protein that helps straighten the bone. So it's caused by defective genes, and these genes affect how the body makes collagen. And the collagen is a certain type of protein that helps to strengthen the bones. Now, diagnosis of this osteogenesis imperfecta is done by symptoms. And by now, DNA testing. Yeah, you know, genes and genetics involved, then you know that you're going to DNA. So the diagnosis is done by DNA testing. And we have the mutation on the COL1A1 and the COL1A2. That encodes now the type 1 for collagen. And furthermore, we have now 4 types. Of osteogenesis imperfecta. Number 2, we have the osteoporosis. And osteo is bone, porosis means porous, porous bone, brittle bone, fragile or weak bones. And this is caused now by when the body loses too much bone, or the body making too little bone, body loses too much bone, or the body making too little bone, and you know, as the bone derived from bone cells. And also that the density and the quality of the bone is compromised. Also the density and quality of the bone is compromised. So that's osteoporosis. The body loses too much bone, the body making too little bone. And it could be a combination of both, the body making, losing too much bone or making too much bone independently or together. And also that the density and quality of the bone is compromised. And we also move to some other, we could have osteoarthritis. These are only some of the disorders of the bone and abnormalities. Osteoarthritis, that is a joint disorder. It's characterized by pain in the joints. As you know, it's a combination of osteo, bone, and arthritis. And these are also relative or connected to connective tissue disorder, which we could integrate with as marfan syndrome. I like the ethlers that so these are only some of the disorders and abnormalities and malignancies of the bone: osteoporosis, osteoarthritis, Osteogenesis Imperfecta, which is caused by defective genetic genes, and they are all characterized by pain, brittle bones, fragile bone, and in specificity, the osteoarthritis, which moves into the joint now, specialized in the joint. You have that disorder of the bone in the joint. Painful joints, dislocation, sometimes a lot of inflammation. Move on to diagnosis, which is by DNA and testing, and by symptoms, especially for the Osteogenesis Imperfecta. And some of these, in terms of cure, can be dealt with correct nutrition And can be nutrition can help to prevent these bone abnormalities. Also, to treat it, we could also use correct nutrition as well as other form of treatment. But we're not dealing with the treatment in this analysis. We're dealing with the disorders and the malignancies. You can state now that the osteogenesis imperfecta, it doesn't have a cure, nor the osteoporosis, but that they can be treated and treated to optimize in the direction of the health for the individual, but it cannot be totally cured. All right, so we'll briefly review the disorders here. I will say now that osteogenesis imperfecta is a group of genetic disorder characterized by fragile bone, and it's caused by defective genes. And we have mutation in the defective gene of the collagen 1A1 or collagen 1A2, and there are 16 such collagens. You have also 5A1, 5A2, but that type 1, type 2, and type 3 make up 80 to 90% of the collagen. 80 to 90% of the collagen. I'm going to do type 1, 2, and 3 make up 80 to 90% of the collagen. So we have that defective now, the genes, mutation in the COL1A1 and the COL1A2 that encode type 1 procollagen. And now there are 4 types of osteogenesis imperfecta. Go through the 4 types here. So other form of bone disorders would be osteoporosis, porous bone or brittle bone, and the body loses too much bone or it makes too little bone, and also that the density and quality of the bone is compromised. So the body loses too much bone, or the body makes too much bone, or both. The body loses too much and make too little. They happen independently and together. Move to osteoarthritis, which is the joint disorder. The bone. This is characterized by a lot of pain in the joint and inflammation. But it has osteo or bone cells root and disorder. Connective tissue disorder, marfan syndrome and danlers syndrome. And that type 1, type 2, and type 3 of the collagen is responsible for 80 to 90% of the protein of the collagen. So we look at now treatment in a separate treatment of these malignancies, bone malignancies. In a separate analysis, and there we will include our implicit AMZ5X12MIPCA as an integral and implicit form of treatment that would support the malignancies due to the bone and due to the bone cells. Note that the osteoporosis, which is the early formation of bone or the evolution of bone cells from precursor bone cells into functional osteoblasts, note that process is on a cellular level, whereas now the osteogenesis takes form on a more macro level. It's the formation of bone, whereas this one is the formation of the bone cells from the stem cells. So that's one difference between osteoporosis and osteogenesis. And that osteogenesis can be normal or abnormal. If it's abnormal, we say it's osteogenesis imperfect, which then leads to various disorders and malignancies due to genetic defect. So we'll take a break here once, and then we will return with treatment of these bone and bone cell malignancies.